So what I would suggest is to start off with is, as we work through these bubbles on the inside, again, you could do this either way, any way you want. I'm going to start off with the degree measures of each of the angles here. So this is 0 degrees, and I'm just going to count around. This is going to be our 30-degree angle, 45-degree angle, 60-degree angle, and 90-degree angle. We add 30 more degrees to 90, that's going to give us 120. We add 45 to 90, that's going to give us 135. And you see 120, we add another 30 degrees. So there's kind of two things going on here. So this is 150 degrees. Again, don't try to memorize it. Remember how it's constructed. All of these, there's 30 degrees, 30 degrees, 30 degrees, 30 degrees, 30 degrees. There's also the 45, 45, 45, 45. And so then we're back down here. Here's 180 degrees. We're going to keep going. We add 30 degrees to that. That gets us to 210 degrees. 180 plus 45 is going to be 225. 210 plus 30 is going to be 240 degrees, 240 degrees. And then 240 plus 30 is going to be 270 degrees. Add 30 more degrees, we've got 300 degrees. I'll skip over this one. 330, and then 360 all the way around. 270 plus 45 is going to be how much? 315? Yeah. 315. Come back. Little degree marks. Okay, so we fill those in. Next, I would suggest let's do all these same measures in radians. So this is 0 radians. Now remember, trigonometry is based upon the radius. So we really do half the circle. And notice that the 30, 60, 90, 120, 150, 180, that gives us 6 segments in the half circle. So this first one is pi over 6. And what we're going to do is we're going to count by pi over 6. So that's 1 pi over 6. This next 30-degree segment would be 2 pi over 6. I'll write that here. You might not want to write it down, but I want it to be recorded here. Reduce this is going to be pi over 3. But remember, we're just counting by pi's over 6. So if I have this 2 pi over 6, this is going to be 3 pi over 6. Which reduces down to pi over 2. Okay, but I've got this 3 pi over 6. I add one more pi over 6, and that's going to give me 4 pi over 6, right? Which reduces down to 2 pi over 3. So you don't really have to memorize these. Again, if we're just counting. 4 plus 1 is 5. So this is 5 pi over 6, and that doesn't reduce, so those are the ones that are kind of nice. And then I add one more, and I get 6 pi over 6, just by counting, which reduces down to pi. Okay. And then again, I come here, I add another pi over 6, so I had 6 pi over 6, I get 7 pi over 6, which doesn't reduce, but that's why I've got these little that's why I'm writing them down, and again, you could choose to do that. Add one more pi over 6, 7, this is going to be 8 pi over 6. And that'll reduce down to, let's see, 2 goes into both of those, that's going to be 4 over 3. So that's 4 pi over 3. Add another one, so we had 8 pi over 6, this is going to be 9 pi over 6. That reduces down to 3 pi over 2. 9 plus 1 is 10 pi over 6, which is going to reduce down to 5 pi over 3. And then 10 pi over 6 plus 1 more is going to be 11 pi over 6. For this one, doesn't reduce. We add one more and we get 12 pi over 6. which reduces down to 2 pi. So we put that in the box. Okay, so we took care of all our 30-degree segments, 30 plus 30 more plus 30 more. Now we're going to take care of that other part, which is dividing into 45, 45, 45, and you'll see some similarities. So the 45s, that's a fourth of a half of a circle. Okay, a little confusing there sometimes, but let me go ahead and change colors here. So 45 is a fourth of a pi, a fourth of a half of a pi. So that's pi over 4. So we get a little bit kinder there. Okay, and then so that's 1 pi over 4. This would be 2 pi over 4, which reduces down to pi over 2. 2 pi plus 2 pi over 4 plus 1 more is going to give us 3 pi over 4. And add 1 more, that's going to be 4 pi over 4, which reduces down to pi. Add 1 more to this, 4 plus 1 is 5, so that gives us 5 pi over 4. Add 1, we get 6 pi over 4. And that reduces down to 3 pi over 2. Add 1 to 6 and you've got 7 pi over 4. Add 1 more and you get 8 pi over 4, which is 2 pi as well. So we've got now all the radian measures for our angles. And you could kind of see each one of these, remember from our activity, has a right triangle in here. This lower one has a 30-degree angle here, our 60-degree angle up here. And if you did the measuring triangles, we actually measured these and we got these values here. What we're going to do is we're going to show how to get exact values, how to remember how to construct the exact values. So let's go with a slightly different color. Let's go with dark green. Okay, so I'm going to start with these the 4 cardinal points, east, north, west, and south, because those will kind of be the easiest to spot. So remember that each of these coordinates is their coordinates in x and y. Okay, so this one we come out, unit circle has got a radius of 1, so x is 1, y is 0. At the top here, the y-axis, x is 0 because x is not moved left or right, y is 1. Okay, so that's that point. Over on this far side to the left, this is negative 1, x is negative 1, y is 0. And then down at the bottom of the circle, we have x is 0, y is negative 1. So we've got those 4 major points. Now all these special angles in between, the 30, the 45, the 60, they're constructed from a triangle. They're legs of the triangle. And remember, the x-coordinate is one of the legs, the y-coordinate is the other half. So since we're dealing with 2 legs, just remember every one of these coordinates, these exact coordinates, is going to be a half. They're going to be just one of the legs, not both of the legs. And again, that's fine. And then notice that x goes from 1 down to 0. So from this point here, at 0 degrees up to 90 degrees, we're going from 1 down to 0. So we're going from large to small. And so the rest we're going to count 1, 2, 3 or 3, 2, 1, depending upon which way we go. So 3 is the largest. We're counting down in the x direction. So we go with 3, 2, 1. And now remember, each of these comes from a right triangle. So we have to take the square root, because a squared plus b squared equals c squared. And you could take the square root of 1, but the square root of 1 is 1. I just kind of do it in the air, so I don't actually mark it because it's going to be 1/2. Okay, but that helps you there. Notice that the y-coordinates are going to go from 0 up to 1, so they're getting larger. So they start small, get large. So 0, and then we've got our 1, 2, 3. And remember, we take the square root of each of these. Square root of 1 is 1, so I just leave it. There are the special angles. What's going to happen is as we go around the circle, these are going to remain to be the special values. It's just in each of the quadrants. Notice over in this, what we call the second quadrant, x's are going to be negative because it's over in the negative side, and y's are going to be positive. When we're down here in the third quadrant, and again, this is probably helpful to have these. Both the x is going to be negative and the y is going to be negative. And over in the fourth quadrant, x is going to be positive, right? Because we're going positive in the x direction to the right, but the y is going to be negative. And I guess if you wanted in quadrant 1, they're both positive. So that will probably be of some help during the test. And I'm going to save this, and if I do any homework problems or review problems, I'll actually be using this, and I'll pull it up and show you how you can do this. So this is helping the memory. So again, if you want to speed up through the rest, if you see the pattern, that's great. I'm going to go ahead and just keep going with this. So on the back side, this second quadrant, as we come through, x is now going from 0 up to 1. And so I count, wait, where am I going? Oh no, x is going from 0 to negative 1. So notice it's this sort of arc here, 0 to negative 1. So it's sort of getting bigger, but again, x is going to be negative. So it starts out more negative, and see, how does that work? So we, again, everything is a half, so we start that. We'll do this 4 times, and so again, practice this part. You'll get faster at it, and I'll bet you can get it done in probably less than 5 minutes. It's a good way to connect everything. And so we're going from 0 to negative 1, so we're going from smaller to larger. It's a 1, a 2, and a 3. Remember, come back, take the square roots, square root of 1, and then all the x's are negative over here, so make sure you've got the negative sign there. Y's are going from 1, which are large, down to 0, so we go from large to small. 3, 2, 1, square root them, square root it, but don't really write it. And those are all positive. Down in the third quadrant, x is going from negative 1 down to 0. So again, we put all our halves. And we're going to count from negative 1 down to 0. So that's a 3, 2, 1 in the x direction, square root, square root, square root. Don't write it though. X's are negative, so negative, negative, negative. The y's, we go from 0 to negative 1, so from smaller to larger. 1, 2, 3. And if you know, one of the patterns you might notice is 3 and 1 go together, but you never would have a square root of 3 and a square root of 3. So it's kind of, once you've got one pattern, you're fine. So then we square root everything. Square root of 1 is 1, square root of 2, square root of 3, and then just remember we're in the third quadrant, so all of the y coordinates are also going to be negative. Last part to finish our unit circle. See, the x's are the first, the x's are the first, so it's 0 going up to 1. So again, we start off, put a half in each of these. And then we're going to count from 0 up to 1, so that's a 1, 2, 3, and we square root it, square root it, square root it, but don't write it. Negative 1 to 2 in the y direction, so that's going from larger down to smaller. 3, 2, 1, square root it, square root it, square root it, but don't write it. And then y's are negative, so put a negative in front of each of these. Okay, so now now we're getting, okay, we got our unit circle. We have everything we need. Again, I would, my preference if I was doing this, I would print it out and practice it with pen and pencil, maybe have multicolor pens and everything. Now, the other thing I want to write down before I get going too far into this is just to make the memory part clear for me, is that we notice that the x-coordinate is the cosine. So x is cosine of the angle. And y, the y-coordinate, is going to be the sine of the angle. So using the unit circle, that's one of the things we can use as a definition. We could also, let's see, what do I want to do that? That's good. So that's a good start. So we've got these values. The x-coordinates are the cosines of particular angles, so I can pick those off. We would want to remember that tangent, I'm kind of write this backwards, is going to be the ratio of sine over cosine. So think of slope. It's y over x, just like the slope in algebra. Sine theta over cosine theta. And actually there is a connection between the tangent and the slope of a line that goes through there. So you'll see that later. So those are good definitions to have. The other way, remember when we were creating these values, you might want to have just sort of the basic triangle here. I think that might be a good thing to have. So a right triangle, choose one of them to be your angle theta, and then label it. So this is the hypotenuse. Since this is the angle, the side opposite is over here, so that's your OPP. And remember, it was kind of a, there's a little rap song. It kind of sticks in your head. So this theta is the adjacent, the ADJ, as they say, okay? And if we did a triangle, again, we're solving some other ones. If the angle's up at the top, up high, this long side here, the side opposite, the right angle's always the hypotenuse, but now it changes. The side opposite the angle is now down here, and the adjacent side is the other leg. Okay, so that's a good thing to have, I think. And then I would have this, if you remember the SOHCAH, S-O-H, Ka, C-A-H, TOA. If you can remember that sine is the opposite over hypotenuse. So sine of theta is opposite the OPP over the HYP. The Ka is your cosine, theta is your adjacent over your hypotenuse. And finally the TOA, the tangent, let's see, do I have enough room, sort of, the tangent of theta gives us opposite over adjacent. So that's a good thing to have here. Again, now as we're going through things, we don't have to rely on memory, which, as we start thinking and solving problems can lead us, but we've got it all here. We can come back to home base. Let me just think if we need, we might need the reciprocal functions, which we haven't given you here on our list, but they're important. And we do expect that you would remember these reciprocal functions, that if we have 1 over cosine, we give that a special name. We could just call it 1 over cosine, but they give that the secant. So that's also, they give it a new name. But the secant is 1 over cosine. 1 over cosine is the secant. So just a way to refer to it. If we have 1 over sine theta, then that's going to be 1 over the cosecant. So that's the C, SC. And just remember, what I kind of notice is a cosine does not, the cos never are together. You don't have a cosine and a cosecant. I guess this was hard to remember. But the cos never are together. Okay, so cosine goes with secant, sine goes with cosecant. And then also there's a tangent, so 1 over tangent is could be referred to as the cotangent of theta. Okay. And since since tangent is sine over cosine, a lot of times we can also remember cotangent would be the reciprocal of that, which is cosine theta over sine theta. So we've got some good memory clues here to get us through. You might want those, what are they, the Pythagorean identities, but you don't have to remember those because we're going to provide them for you. So we got Pythagorean identities here. So these are there. We have the sum and difference identity. So we can add two angles, and this will help us in getting exact values. There are probably going to be some questions like this. There are the double angles. So if I've got sine of 2 times an angle, I can break it up this way. Cosine of 2 actually has 3 different identities. And again, it just depends on what I'm trying to solve for. That's sort of the thing that's nice with trig, is you can get creative. It's also the part that can make it a little confusing at times. Which way do I go? It just takes some experience. And finally, the tangent of 2 theta to alpha, 2 of the angle is here. Then for solving triangles, this takes us to our very last unit law. We have the law of sines and law of cosines based on a right triangle with sides A, B, C, angles big A, B, big C, and those are those opposite there, and so law of cosines. So we've got all these formulas that should allow us to get through. We have a template that will help us in creating the unit circle and some of the details we need to. Again, practice it, watch it, and you'll be in good shape.